Welcome to this spoken tutorial on pH scale using interactive PhET simulation. In this tutorial, we will learn how to use interactive PhET simulation pH scale. To follow this tutorial, learners should be familiar with topics in high school science. Here I am using Ubuntu Linux OS version 14.04, Java version 1.7.0, Firefox web browser version 53.02.2. Using this simulation, we will learn to determine whether a given solution is an acid or a base, arrange acids and bases according to their strength, determine the concentration of hydroxide ion, hydronium ion and water at a given pH. Using this simulation, we will learn about pH of a solution, effect of dilution on pH of solution, logarithmic and linear scale. pH scale is a numeric scale used to specify the acidity or basicity of an aqueous solution. pH is a measure of hydrogen ion concentration in mole per liter. pH is negative logarithm to base 10 of hydrogen ion concentration. For acidic solutions, pH is less than 7. For basic solutions, pH is greater than 7. For neutral solutions, pH is equal to 7. Use the given link to download the simulation. I have already downloaded the pH scale PhET to my downloads folder. To open the simulation, right-click on pH scale HTML file. Choose the option Open with Firefox web browser. The file opens in the browser. This is the interface of pH scale simulation. The interface has 3 screens: Macro, Micro, My Solution. Let us begin our simulation with Macro screen. Click on Macro screen to open it. This screen has a pH scale on the left to display pH range from 0 to 14. A green probe attached to pH scale to measure pH. And a pH meter to show pH of the liquids. A water pump on the right side of screen to add water. A graduated water container filled by default with chicken soup. A pump to remove solution is attached at the bottom left of the container. A dropper to add liquid. A drop-down box to choose one of the liquids. By default, chicken soup is selected. A reset button is provided at the right-hand side bottom corner. Click on the drop-down arrow, scroll to battery acid and click on it. Notice that the container is filled with battery acid up to 0.5 liters. Drag the green probe into the container and observe the pH. Meter shows the pH value as 1.0. As pH is less than 7, battery acid is an acidic solution. Now click on the water pump to add more water. Increase the water level up to 1 liter. Observe the change in pH on addition of water. Now pH meter shows pH value as 1.30. Notice that pH of battery acid increases on addition of water. This is because hydrogen ion concentration decreases with dilution. Now we will select another solution. Click on drop-down arrow, scroll to hand soap and click on it. Container is filled with hand soap solution. Here, pH meter shows the value of pH as 10.00. This indicates that hand soap is basic in nature. Click on water pump to add water to a hand soap solution. For 1 liter Hands-off solution shows a pH value of 9.70. We can see that pH of hands-off solution decreases on dilution. This is because hydroxide ion concentration decreases with dilution. Click on the bottom pump to remove half liter of hands-off solution. Click on the dropper and increase the level of hands-off solution to 0.6 liters. Notice the change in pH. It increases as concentration of hydroxide ion increases. Now, we will arrange the acids and bases according to their strengths. For that, we will check the pH of different liquids. Click on drop-down arrow and select blood. Container is filled with blood up to 0.5 liters. Meter shows the pH value as 7.40. As pH is greater than 7, blood is a basic solution. Again click on drop-down arrow and select orange juice. Meter shows pH value as 3.50 for 0.5 liters. It is clear that orange juice is an acidic solution. According to the above pH values, the order is as follows. Hand soap is greater than blood, is greater than orange juice, is greater than battery acid. As an assignment, check the pH of each liquid and arrange the liquids according to the pH range. Now, we will move on to micro screen. Click on micro screen at the bottom of the interface. This screen has the following tools. A pH scale on the left hand side of screen. A switch on the top of pH scale to select between concentration and quantity. A red button with a minus to hide pH scale. A switch at the bottom to select between logarithmic and linear scale. Check boxes to select hydronium ion to hydroxide ion ratio and molecule count. In the pH meter, a red button with a minus to hide pH reader and value. Click on the drop-down arrow and select soda pop. Container is filled with soda pop. pH meter shows pH value as 2.50. It means soda pop is an acidic solution. As soda pop is acidic, concentration of hydronium ion is high and hydroxide ion is low. Then click on quantity. We will see the number of moles of hydronium ion, hydroxide ion and water. Let us change logarithmic scale to linear. To do so, click on linear. The pH scale changes to linear mode. We also see that pH values become linear. But we will not use linear scale as pH is in logarithmic scale. Click on hydronium ion to hydroxide ion ratio checkbox. A large number of red dots are seen in the container. These are hydronium ions. A few blue dots that are seen are hydroxide ions. To see count of molecules in soda pop, click on molecule count checkbox. Count of hydronium ions, hydroxide ions and water molecules in soda pop is seen. Let us see how dilution affects the number of molecules. Click on water pump, fill the container up to 1 liter. Observe the change in molecule count. Note the increase in pH value. pH becomes 2.80. As an assignment, measure the pH of blood sample. Observe the change in molecule count and hydronium ion to hydroxide ion ratio after dilution. Now, we will move on to My Solution screen. Click on My Solution screen at the bottom of the interface. My Solution screen has the same tools as that of macro and micro screens. This screen also has some additional tools. A graduated container on the right hand side of screen. a pH meter to adjust pH directly. This screen allows direct manipulation of pH or ion concentration. In this screen, we can make a solution of our choice in two ways. By moving the hydronium ion or hydroxide ion slider on pH scale. By clicking black arrow upwards or downwards. Let us move the hydronium ion slider upwards. Notice that simultaneously, hydroxide ion slider also moves downwards. Let's make a solution of pH 4 by clicking the black arrow downwards. This is an acidic solution. Now, click on hydronium ion to hydroxide ion ratio and molecule count checkboxes. Notice that molecule count for hydronium ion is 3.01 into 10 raised to 19. As an assignment, make solutions of pH 7.0 and 9.0. Observe and compare the change in molecules. Let us summarize. In this tutorial, we have learnt about interactive FET simulation pH scale. Using this simulation, we have learned to determine whether a given solution is an acid or a base, arrange acids and bases according to their strength, determine the concentration of hydronium ion, hydroxide ion and water at a given pH, pH of a solution, effect of dilution on pH of solution, logarithmic and linear scale. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Please post your timed queries in this forum. This project is partially funded by Pandit Madan Mohan Malviya National Mission on Teachers and Teaching. Spoken Tutorial project is funded by NMEICT, MHRD, Government of India. More information on this mission is available at this link. This is Minal Ghoderao from IIT Bombay. Thank you for joining.